Hello, and welcome to session one of the CJADC2 at the Edge Virtual Summit, enabling trusted networks and systems for CJADC2. My name is Dan Taylor, Technology Editor with Military Embedded Systems, the SOSA Special Edition, and the FACE Special Edition. I'm also moderator for today's event. To learn more about Military Embedded Systems, please visit militaryembedded.com and check out our articles, blogs, and podcasts on military technology. Our speakers for this session are Taymor Kamrany, Capture Director, Mercury Systems Integrated Processing Solutions, David Gregory, Chief Architect, Technical Fellow at Curtiss-Wright, and Patrick P.K. Kelleher, Regional Field Application Engineer Manager, Real-Time Innovations, RTI. This session is sponsored by Mercury Systems, Curtiss-Wright, and Real-Time Innovations, RTI, and hosted by Military Embedded Systems Online and Open Systems Media. Before we begin, I have some housekeeping items. This and all Open Systems Media virtual events are copyrighted and may not be recorded or used in any way without the express written consent of Open Systems Media. This session will consume about 40 to 45 minutes, leaving the remaining time for the question and answer session. Now let me show you around the console. You'll find on the right-hand side an area where you can enter your questions in real time. We encourage you to ask questions throughout the session while the question is still fresh in your mind. We'll address as many questions as we can during the closing Q&A portion. If you have a question for a specific speaker, please note so at the beginning of your question, or I will offer the question to all our speakers. If you have a question pertaining to the event operation itself, one of our technicians will get back to you during the session. Please note that as much as we'd like to, we may not be able to get to all of your questions today. In that case, someone may get back to you after the event with more information. Across the way on the left-hand side, there's a resources section, and that's where you can find the slides being presented today. Below that, you can view today's speaker information. Two additional features that we're really excited about. Your console is now customizable insofar as you're able to manipulate all these widgets, Q&A, resources, and presenters for your ideal viewing experience. Expand them to get closer look or close them to have the presentation window automatically resize around. For maximum screen size, close them all and or utilize the full screen control in the upper right-hand corner of the presentation window. To bring them back, simply click on the buttons on the bottom middle dock. In an effort to make our webcasts more accessible this year, we have added closed captioning capabilities in nearly a dozen languages. To enable this functionality, simply click on CC in the upper right-hand corner of the presentation window and select your language of choice from the drop-down menu. This session and event will be archived online at the same URL you used to join today's live session and will be available within 48 hours. Once up, it will be available for at least 1 year. Now I will turn it over to PK to get us started.
Thanks, Dan. Great setting the table for me. So welcome all. As Dan has already introduced me, I'll skip that, but call me PK, not Patrick, because no one calls me Patrick. So let's get started with this. So starting at the very beginning, why do we want and why do we need CJADC2? Well, way back in the early 1970s, a guy named Colonel John Boyd came up with this concept of the OODA loop. The OODA loop, which you've probably all seen at least once in your careers. You know, you observe what's going on, you orient to figure out what to do, you decide what to do, and then you act upon that. And you just repeat this process when you're involved in a conflict, and it's been adopted fairly heavily. So in the early 2000s, to go through a process of the OODA loop would take days or weeks. And I saw someone once said sneakernet. Somebody else said, no, this is really swivel chair. So this is literally a guy getting a thing in, turning to the guy next to him in a swivel chair, handing paperwork across. And this could be days or weeks to go through this loop. When we got to the early 2020s, we've actually gotten this thing down to, hours or days using, MLS systems, multi-level security, or networks and such. But now in the year 2022, they really need to get this down to, minutes and seconds using, of course, our integrated multi-domain operations networks. So this is why folks said we need CJADC2. Well, what is CJADC2? So in terms of CJADC2, starting with the what the thing actually means, which is a good place to start. Starting from the back of the large collection of random letters, command and control. I think people know what command and control are. Command and control, literally, what we're trying to do with that OODA loop. So the AD is for all domain. All domain meaning from under the ocean to on top of the ocean to on the land to just above the land flying around to all the way up into space for all the different domains that exist in modern combat. The J stands for joint. Joint meaning not just the Navy doing all of those things, but the Navy, the Army, the Air Force, the Marines, Space Force, etc., all the domains. And now the C in CJADC2 means for combined. Combined being not just the United States, but the United States plus NATO plus our Asian allies plus whomever we may run into in a particular conflict. So literally having a combined way of managing all of this information. And so what is this information? It's live real-time data. That's really what the lifeblood of CJADC2 is. So this data is coming from a huge different array of sensors. So, radars, sonars, commercial stuff, military stuff, signals intelligence, you name it. All this data is going to be coming in to all of these different allies and services, etc. And this data sources are going to be in contested space as well. And so with this wide range of sensor platforms, there'll be attacks made all over that attack surface. So you can't expect your drones to be flying around unencumbered for long periods of time. And so we really do need to have AI and ML to build this trust in the data. And so how does this look in terms of a real world event? Well, this is an article from Time, but there's all sorts of articles on this. In terms of the Iran missile attack on Israel, there were literally 5 different nations who participated in defending Israel. There, Israel himself, United States, British, French, and Jordanian all combined to fight off that over 300, and I've seen numbers higher than that as well. So a real world application of not a design from scratch CJADC2 system, but an ad hoc CJADC2 system that performed quite admirably. So, and we're doing this presentation without an audience that can ask questions live. So I usually pause for questions. I won't now. Feel free to ask questions in that chat bar as well. So in terms of a real world JADC2, which turns into a CJADC2 system, I will talk about the Integrated Battle Command System, IBCS, which actually has changed its acronym and name, but it's always been IBCS. So this is a command and control system for the U.S. Army for missile defense, air defense. And so if you look at the diagram in detail, I mean, there's a lot of stuff on the diagram. You've got all of the sensors that might be feeding data into this, including sensors from the Air Force with AWACS, or the Navy with the Navy AWACS, or the Navy with Aegis CEC. One thing that's not shown on here is the Marines have a Gator radar that's now been glued into IBCS. And IBCS itself has now been sold to foreign countries and will have a joint concept of IBCS as well. So what IBCS does is it gets your best sensor for the threat that's coming in and selects the best effector. And so how does it do that? Well, it's modular. It's a very modular system where you can bring in systems that are exceptionally old. The AWACS aircraft were flying in the early 70s. And by adding in appropriate intelligence, now glue those old radars, those old sensors into a modern system with all the modern latest and greatest missiles. And so a key, very much key features of IBCS and all JADC2 systems is they do have to be absolutely resilient, redundant. There can't be a single point of failure. You really have to be able to talk to new technology as it shows up and bring in old technology as well. So a very, very effective example of a current JADC2 moving to CJADC2 system. So how does JADC2 and CJADC2 do all that with all this data? Well, the way to do this most effectively is data centricity. So if you're looking at what is a data-centric design for your system, if you look at in the past, you've got a data base on the top line. On the bottom, if you're looking at a data-centric system using DDS, which is what RTI provides, you've got a data bus. And so how does that work? Well, on the database side of things, you have a data-centric writes and reads into the database, and this data is at rest. If you go to a data bus, DDS type of system, you now have data in motion. So to get data out of that database, I do a database lookup, a database query. In DDS, the concept of getting the data out of this data bus that's data in motion is a subscription. And so the two are very much analogous. If you're not familiar with DDS, you can look at how a database operates. DDS operates the same way. And this is how systems like IBCS operate, where literally the data is accessible to every single unit in the system that needs to access this data. And you can now prioritize data and really shape how this works in this real world system. So as part of why stuff gets designed into JADC2 and why data centricity and everything else is good, well, if you've not heard of MOSA, where have you been? MOSA has been around for 5 years now. It's actually a US law where you have to have modular open systems approach in any major defense acquisition programs. And this was, it's actually 10 USC 4401 is the actual law. And so, what does that mean for MOSA? It means that I need to employ these 5 principles whenever possible when I'm designing a new system, any system design after 2019, as it were. And so, key parts of MOSA, of course, are all 5 of these, but open standards and conformance are important for this. You can't put in proprietary standards and have an open system. Another key thing to worry about for MOSA or look at is it's an approach. This is not an architecture for a system. This is an approach to how to design your systems. So very, very important to adopt MOSA because it helps JADC2 and it's the law. So far I've talked about all this stuff. I actually haven't mentioned what about trusted networks, which is what, if you're paying close attention, what this session is about. so, um, so trusted networks, you have to consider the network to be the adversary. You have to assume that you're operating under an untrusted network. It could be public. It could have people trying to interfere with that. It could have bad actors. It could really be a challenge to manage it for human beings, the IT model. And you'll see when I advance the slide that not only is it challenging for IT folks, it's even more challenging for real world systems. So this is just a graphic I took. It's an old graphic, but it's illustrative of the problem. If you had a commander up on one of these vessels and a incoming missile was coming in, him having to log on and verify his ID and have a text message sent to his phone before the missile strikes the vessel is not the optimal approach. So for machines, you really need a dramatically faster way of handling trust in your networks. So just as an example here, this is how zero trust works for humans. One of my colleagues did this and screen capped him. So in a zero trust thing, you get your sign on, you put your username, your password, and then you get another second factor, a push notification saying, are you really who you are saying you are? Establishing this trust on an open network. So in terms of machines, it is a whole different problem. The good news there is that with DDS, this industry standard that RTI has a solution for, there is a portion of the specification called DDS security. And DDS security actually enables that zero trust and a whole bunch of other trusted aspects for machines. So what happens if a rogue actor shows up and tries to log onto that secure data bus and tries to intrude? Well, when you have a DDS secure system, they can dynamically banish those rogue actors, those rogue applications. They can say, yep, get rid of this. Here are new keys. We've authorized you in the past, but we're going to automatically redistribute your new keys. And if you've got historical samples that you need to retrieve as well off this, we'll re-encrypt those with those new keys as well. So this really allows you to support in a secure, trusted environment applications running for days, weeks, years, as it were, and change on the fly if you need to how things are authorized. As new systems show up and leave your network, you can absolutely do that as part of the DDS security. So a few other words on DDS security. As I noted, it is a standard. So if you go to the object management group, you will see all the information on DDS security and the standard. It has defined multiple different plugins, so I can authenticate systems as they show up. That trust portion of the network where a new system appears and I can authenticate, yes, they are who they say they are. I can do access control on that new system. So if this system is a sensor that's only going to be publishing data, I will have it so only is accepting data from it. There's no way to change what's going on. We can have cryptographic libraries in there, which are all very much customizable. So you may have different levels of cryptography if it's a US only system versus a NATO system, et cetera. And of course, you can log what's going on for those systems if there's any sort of intrusions, as it were. So now we've talked about the trusted part. Let's talk about the combined part of CJADC2. When you've got these secure networks and you may have other nations coming on. And so this block diagram came from actually a real world simulation presentation that was done, I'm pretty sure it was at ITSEC or several years at ITSEC, where you can have literally multiple different data buses defined. There may be a local one, a US one, local ones on different aircraft or vessels coming on. And the concept of a secure gateway now gets brought in, where I can have on the secure gateway different security parameters on one side of it, talking to maybe the South Koreans, then on the other side, which is when talking to the Japanese. And so you can literally have a very complex CJADC2 system that's going to be hierarchical. It's going to be loosely coupled. It's going to have systems being able to come and go and be able to have security and trust as part of that whole system. So a real world example of where things are moving to and are actually, heading toward that pretty quickly, as the next slide will show. So in terms of winding this up in the last couple of slides, we started off with the OODA loop. There is a lot of discussion about, is that the right thing? And there are smart people who have said, no, it needs to be called sense, make sense, and act. But there's also, I think, even newer versions of that have different words. But essentially, you want to be able to have all of this data, the information, the awareness, the intelligence, the understanding, the decision making, the execution, and the assessment of what happens, all as part of a bigger system. So in terms of how the US branches are doing this, the Air Force calls their JADC2 Advanced Battle Management System, ABMS. US Army has Project Convergence, and the US Navy, always one with a cool nickname, has it called Project Overmatch. And a real world example of this, and I cleverly put the C in on top of the JADC2, because it really is a CJADC2, is an article from Breaking Defense just a couple of weeks ago about a new initiative, the Pentagon's Global Information Dominance Experiment, which is going to have a carrier strike group connected to multiple allies as it goes through multiple contested domains about a year from now. So a literally real world example of JADC2 turning into CJADC2, and it's going to be happening soon. So wrapping this up, CJADC2 really is happening now. All of the text on the left side of this thing and this whole slide in general is from RTI's landing page for JADC2. And I've told them we probably should put a C in front of it, make it CJADC2. So feel free at the close of this, click on that link and see there are literally hours upon hours worth of materials and how real world CJADC2 and JADC2 devices and systems are put together. So absolutely feel free to go there and check that out at your leisure. With that, thank you very much. And I will turn that over to Taymor, who will be doing the next phase of this. On to you, Taymor.
Great. Thanks, PK. Appreciate it. Over the next 10 to 15 minutes, my plan is to demystify JADC2 and how industry and government are collaborating to build a trusted and resilient network. And for folks, if you have questions, please put them in the chat. We'll try to get to as many as we can. We do have time at the end of this session. In addition, we do have the handouts that you can take home with you. And for those that want to reach back out, there is a contact page at the very end of each one of our slides. Now, imagine you as the commander walking into a theater of operation, and you look at this image on the right side. This is what you're faced with. Many assets on the ground, air, sea, subsurface, and you don't have days anymore. You have minutes or even seconds to figure out where everything is and where you need to put the assets and the effects. And so the problem that the commanders have is not new. It's always been here. We're not trying to boil the ocean here. DoD, J6, as well as services have gotten together and they put together the JADC2 doctrine, which basically is intended to develop a resilient network to speed up decision making. That's really what JADC2 is about. You heard PK mention data probably 30 times, and you're going to hear it again from David as well as myself. Data is key. Data is gold. It's the ultimate currency, and data needs to be protected. And so JADC2 is, as a doctrine, is not a program of record. There is no funding associated with JADC2, but it will be implemented across many programs across all services. And the intent really is to identify the sensors and link them to the decision makers and use AI ML to help automate the process and provide the commander with solutions so that they could go ahead and take the next step. So man will always be on the loop. And that's one of the questions that a lot of folks have, in that will all this be automated? And the answer is no. Now, before we get any further, for those that are still wondering what JADC2 is and how can we boil the ocean, all we have to do is look back into the 1990s when the internet revolution started. And if you recall, back in right around 1994, I think it was, industry and government collaborated. They came together. They laid the foundation for what the internet is today. What they did at that point was basically provide the delicate balance between industry leadership, that being the investments, as well as government oversight to ensure that we have equal access to all the data. And so you heard about ICAM briefly from PK, and JADC2 is beyond that. The intent here isn't for DoD to solve all the problems. What we want to do is actually team up with them and collaborate and actually put together the solutions. And so what you really need are high-level requirements, because the high-level requirements will actually bring in the industry investments so that we could help fuel the innovation, and government and users will essentially modernize their IT system so that they can have access to information across all domains. And so the image on the right is something that J6 put together, and that in itself is JADC2. You have the sensors, you have the shooters, you have the domains, and the bottom line is that you want to be able to sense, make sense, and act at all levels, all phases of war, across all domains with partners. Sounds like we're boiling the ocean, which we are, but it's really not that complicated. And so as a capture manager, what do I look for, right? I look at the vision, I look at the customer stated needs, right? The intent here really is to reduce the kill chain and the OODA loop that you heard from PK. We heard repeatedly from the services that they want common and open systems. We heard from industry that we can in fact provide that. And so there's a good middle ground there. Now, industry will be tasked for the development and maintenance, but the warfighters are going to focus on the fight. So industry needs to come in with the investments. Mercury Systems, over the past 5 to 10 years, we've averaged roughly 10 to 15% of our annual revenue in IRAD. And so we invest heavily into the key areas that will help enable JADC2. And the hot buttons, quite frankly, if you look at the image on the right, is data processing, data speed, data security, and transport latency. And that in itself is the heart of the issue. And that's what I plan to talk about over the next few slides. But before you actually get into it, if you really look at what we're dealing with, if you want transfer of data across all domains between different systems, what you're really dealing with is also a security issue, in that not every user is going to be able to access the information. Not every user is going to have access to the information. And more importantly, the security protocols restrict that. And so before you even get into solving the issues, DoD needs to work with industry. Bottom line for industry, though, is that if you want to participate in JADC2 and identify solutions that could help the warfighter achieve their mission, you have to have trusted supply chains. That by far is a primary concern. You have to have the right cybersecurity protocols. You have to be able to mitigate insider threats and secure facilities with cleared people. If you don't have any of those, then more than likely you're going to be the weakest link, and clearly the weakest link is going to break the JADC2 network. Over the past 40 years, Mercury Systems has put together processing technologies. That is what Mercury Systems is known for. We're a processing house. The image that you see on the right are all fielded products. Everything from our enterprise servers to our blade servers to our encryptors, as well as the two processors that you see on the top right. If we're looking downstream and we're actually going to use AI ML, take a massive amount of data and bring it all in, the key is that you want to be able to take security and implement it across. And so you have to have rugged security. You have to have cryptography, signal processing, so that you could protect the data all the way down to the chip level. So you'll hear about anti-tamper cross-domain solutions when you go into any JADC2 forum. The intent here is not to slow down the process. The intent isn't necessarily to limit anybody with access. The intent is to protect the data, because data is gold, and that in itself is at the heart of the problem. Mercury Systems is right there solving those solutions. The products that you see on the right are fielded. We do have data sheets that you could go to our website and download and read about them. And if you have questions, you can certainly ask about each one of those. We'd be more than happy to help address those. The other piece of it is really the secure storage and communication at the edge. When you're deploying any product out in the field, what typically happens on the military communication side, the most common use case is NSA Type 1 encryption. So you want to have encryption at the edge. That's where we're focused on. That's what we're dealing with. And so some of the solutions that we've come up with over the years, in parallel to JADC2, and they've been fielded for years now, are the rugged data storage systems that you see here on the top. With Build Secure, which is the terminology that we use to identify and to solve the security issues. What the data sheet in this one, if you download it, what you're going to find is an incredible system, for example, that has high-speed, low-latency process and security protocols that essentially addresses the heart of the issue when it comes to JADC2. JADAR, for example, is another encryptor module that we have fielded, and that's something that we work with on a program with DARPA. Again, another solution that can be used today. We're here, we're ready to help, and we're ready to partner with industry as well as government, and we are working. But what I want folks to know is that we are ready, and we actually are leaning forward. As well as many firsts. So, for example, we have the first certified solid-state drive for NASA's program, and also the first space-based qualified solid-state drive, as well as a processing solution that we just recently launched that you can read about on our website. So storage as well as processing is key. What I want to leave everyone here with is that Mercury Systems has the pedigree, 40 years in the processing business, 30 years in the security business. We have the expertise. We build security into our systems, not on top of them, from the bottom up. And so anything that we put out, you can be confident that it's going to work. It's going to work the first time and every time. And most importantly, it's going to have the security features, both physical and cybersecurity protocols, that will help the warfighter access information, deploy the right assets, and achieve their mission success. And when it comes to AI, which is the biggest buzzword in industry now, we actually have been using systems and modules all the way down to the chips to be able to take a massive amount of information, process it safely, store it safely, and disseminate it safely, so that we have the commanders, we have the warfighters, we have all the end users accessing information at the edge. And so I leave you with the one key piece and advice is that, Mercury Systems has been here. Like I mentioned, we spend roughly $100 to $140 million on the average over the past 5 years in IRAD to help field solutions. We're ready to help, and I look forward to your questions. So I'll tee it off for David so he can come in and take it from here. Over to you.
Yeah, I guess I'm not sure my screen is updated. Am I on right now?
Yes, we hear you.
Perfect. All right. Well, thank you, everyone. Thank you, Dan, Taymor, and PK. And hello, everyone. I am David Gregory with Packstar Communications within the Curtiss-Wright Defense Solutions. And thank you for everyone being here with us today. This enabling trust topic for this session has actually proven to be more challenging to prepare for than I had actually expected. I interviewed with several trusted coworkers and some of our industry partners. And honestly, instead of finding closely aligned solutions and guidance, we kept kind of tripping in rabbit holes and opening up containers of very diverse and very passionate worms, which ultimately highlighted much of the topics which have already been discussed, but highlighted for me the paramount challenges being tackled within the vision of CJADC2. We need to make better, common, joint, unified decisions faster ahead of our adversarial near peers. In the session's preamble, Military Embedded offers success of JADC2 systems depends on the ability to interoperate across multiple systems and multiple domains, which supports Curtiss-Wright's statements from 2021 when speaking about how MOSA will enable JADC2, that common standards are essential for interoperability across platforms. Strong and robust standard security approaches are needed to guide open standard applications and adaptation. Ergo, standards are fundamental for the security. But what about trust? So here, the speed and success of operations is driven by trusted data-driven decisions. So how quickly and can qualified trusted decisions be made? As standards are fundamental to security, security is ultimately fundamental to trust. Here is on this screen, here is kind of my oversimplified take on the architect of what I kind of dubbed architecture of trust. How do we give the decision makers the best chance of making the well-justified, well-supported, unified decision in the time that is needed? How do we make sense of the sensing? Between detection at the bottom there in the perception layer and the decision layer is a vast ecosystem of IT infrastructure, process management, policy enforcement, data protocols, data confirmation and exchange, analytics, and on and on and on. I believe trust ultimately will begin at the perception layer, at the sensors where the data originates. What is being detected and how is it being detected? Is the anomaly sensed by multiple sensors offering reinforcing perception? Are the sensors themselves trusted and validated? Is the sensor data considered an informational root of trust? Is the data from the sensor securely hardened and trusted? Or excuse me, is the network from the sensor securely hardened and trusted? CJADC2 must be constructed upon a unified foundation where trusted data sources can be ingested, stored, shared, and processed reliably, often offering trusted results. I know this sounds easy, right? Everybody does, but I recall in my own experiences supporting efforts to jointly inform against improvised explosives and threats being used against our own services and allies in the 2000s and 2010s. We worked to prevent and eliminate harm through data collection and analytics. We always tried to be what we called left of the boom, or before the explosion or the damage. Even though it wasn't called an architecture of trust at the time, significant resources were applied to construct a trusted system focused on just one problem set, which would be a very small version of CJADC2 at the time. Many of these topics, maybe not all of them on the screen here, had to be addressed. And the most significant issues were always about the data. Where do we get it? How do we get it? Is it trusted? Is it still valuable and meaningful? And can we be correlated with other information that we have? This was before MOSA, machine learning and AI. In the early days, it was mostly brute force and strength. Data adapters had to be created for each data stream to standardize so databases and indexes could be optimized. So applications could be written and to correlate and analyze, so decisions could be well informed. It actually took years of tuning with educational trial and error before the system was efficient. Security was always more of a tripping hazard because it wasn't baked into modular, interoperable standards. Trust is essential for quality decision making. The collection of MOSA standards, as some of them have been mentioned, plus like information, integrated sensor architecture, things like FACE, NIAP, are providing the architectural building blocks for systems of trust. This graphic was already shown, but this again is kind of is a nice graphic that's worth 1,000 words. Again, as described, right? Data flow is flowing in across the architecture, entering interoperable domains for sensor and data information exchange. Systems that that interface together, forming systems of systems, networks for collaboration, analytics to make sense of sensing, all feeding into the all-important OODA loop or decision cycle there in the middle. Like an automobile, if any of these parts are missing, or depending on the criticality of said part, the automobile won't function as expected, or if at all. So trust is established by security. So what is the euphoria? Modular standards that can be used as building blocks to create trusted systems. Well-formed, interoperable, open standards and protocols with implicit security baked in. Collaboration standards to account for and enable cross-domain transactions, establishing those trusted relationships between those domains. How do we get there? Well, we have a lot of reference architectures. We have defined components and interface controls. We need capability packages that outline necessary use cases and with the appropriate standards applied. Protection profiles that specify modular requirements and component validation methods to establish and measure of trust. Network and system administration is going to be paramount. We must take advantage of software-defined everything, from software-defined networks, from software-defined infrastructures. That's critical. Self-healing and auto-adjusting components are a must. This ultimately it ultimately always will be and still is a very large IT problem. So we must start somewhere, and here we are. Our open standards, do we have them? What are they? Well, yes. For example, some of them have already been mentioned, but there is the National Information Assurance Partnership. There's National Institute of Standards and Technology. The Data Distribution Service was mentioned earlier. These and many other security methods for JADC2 need to account for progressive risk evolution, not just iteration. Again, we need to find ways to stay left of the boom before the breach, before the damage. So at the scale of CJADC2 and the vision thereof, we need to find ways of being prophetic. We need to find ways to prevent the risk and not just simply discover the vulnerability. For infrastructure, we must simplify. We must simplify whenever possible. We must use strong management tools to eliminate configuration and mistakes. We must be able to triage rapidly, and you'll discover many of those unknown risks. We of course must be able to continue to establish and promote those interoperable standards and promote how they will be employed and where they will be employed. That is what, those are things that as industry we need to continue to work together on. Inferencing is also, it is an art, but it needs to almost become a science. This is probably likely the most difficult, as we must learn quickly. Inaccuracy in our inferences for our decision makers will either, one, continue to generate excessive derivatives of our data, so false positive or false negatives. If we set our inferences too sensitive, or if we aren't quite there, we will miss connections that should have been found and should have been shared and should have been passed up. So here in closing, standards are fundamental, standards are foundational, but will only take us so far. Systems can be tailored, biases can be accounted for, sensors and analytics will improve, and threats will continue to evolve. So these standards, and how do we enable trust and security? Standards should not displace original thinking, but rather drive technology evolution. And security standards must enable trust to support experienced human decision makers. I thank you, and I pass it back to Dan.
All right, thank you, David, and thank you, Taymor and PK. We'll now move on to the Q&A portion of our session. I have a few questions here for you all. The first is directed to PK, although everyone is free to chime in, of course. PK, are there any specific domains where moving to CJADC2 is more difficult or easier to achieve?
Great question. As you might guess, going from deep under the ocean to up into space and a satellite, there are different communications technology involved with all those things. The most challenging, I think, in terms of data by far is underwater, undersea, where you're limited to, very, very low baud rates, 100 baud, 200 baud. It's very, very low speeds, or you're limited to being tethered. And so that's actually being worked on. There's actually a relatively new, and now really becoming very popular standard called UMA, and it's not spelled YU, it's UUMA, and that's being used a lot in terms of subsurface and surface autonomous vehicles, which then can be, plugged in as a MOSA thing into an overall JADC2 system. The other one that's challenging is satellites, where they disappear over the horizon every few minutes, and so there's work being done with clustering of satellites and being able to communicate from satellite to satellite and have that, and so that is being worked on very, very heavily. In terms of what is easiest, well, anytime you've got something like IBCS, where you've got actual hardwired cables or RF links that are very much fixed and are high speed, that's the easiest to do. The Navy is good at that as well, where you can have all the stuff inside a vessel and then going between vessels also high speed. And so, yeah, where it's easiest to do JADC2 is where you have high speed data links. Where it's hardest is going to be where you have the lower speed data links. So anybody else wants to chime in, feel free. Go ahead.
Yes, PK, I appreciate it. That's a great point, in that most vehicles, whether it's airborne, sea, undersea, air, and now space domain that we're looking at, they typically don't have the storage or the processing capability to take the sensors that they have and actually make sense out of them. And so that's what we refer to as processing at the edge. And so, to PK's point, We can, in fact, solve the problems piece by piece. First step would be is to do your processing at the edge. You don't necessarily have to come back to the data centers with all that latency in between, because we're talking about seconds, like you mentioned earlier, and not days, as was the case, 30 years ago.
Excellent. Thank you. Thank you both. So this question is for David. Can you talk about some of the gaps or needs that industry should focus on in this area? Where can industry get involved?
Definitely. So partnerships, so these strategic partnerships. So as technology is implemented, it's, we go to trade shows all the time, industry shows of all kinds. And, we have a lot of frenemies at all these shows, but then, these standards, they aren't implemented in the same way every time. Just because we have interconnects defined and ways, I'm thinking of like CMOS right now. It's underneath the SOSA standard or SOSA consortium. It's a standard which is being pulled together by the Army, and then we have a reference document. But how it is ultimately getting implemented, I can think of 6 different companies that are implementing it, all slightly different. So yes, business has to be, have to be profitable in order to maintain business. But in order to see, progress in this space, we do have to be able to collaborate. We do have to be able to work together, because and it's okay. We can set our pride aside. It's okay if somebody has a better idea, and it's one of those things where we can work together and we continue to mature those ideas. And that is typically how industry works, right? There is this leapfrog effect. You just go back since the beginning. It just keeps happening over and over. So I think working together, finding a way and doing that well, finding a way to ensure that everybody's taken care of, everybody continues to be able to pay their bills, but ultimately the end state is we have to continue to evolve and evolve rapidly in order to kind of stay ahead of our near peers. Over.
Thank you. Another question for you, PK. Can you talk about the current conflicts in Ukraine and the Middle East and what kind of lessons learned are most useful in this area?
Great. Yeah. There's nothing like a actual war to let you know that the stuff you've been working on works or doesn't work. And so I think in Ukraine they would love to have an IBCS system. Right now, when a missile threat occurs, they may have a half dozen different radars, and they may shoot at something that costs nothing at all to produce with a multi-million-dollar Patriot missile, where if they had something on IBCS, they could shoot it with an actual projectile fired from a gun. And so they would love to have that. Unfortunately, it's going to take too long to get something like IBCS to Ukraine, but other countries like Poland is adopting IBCS because they see what's going on and they know that's a good idea. And so the speed of how fast these missiles move means that you pretty much have to shoot with what you have handy, where an IBCS you could now prioritize this and have literally the best sensor, best shooter. And then I think the conflict in Israel, for the United States and the allies has really been more about defending cargo vessels in the Red Sea and protecting Israel, helping protect Israel from missile attack. And so I think we've, figured out that yes, indeed, the more we can collaborate on the CJADC2 like systems, where if you have a flotilla of US, French, and British vessels, figuring out who's going to shoot at this thing and who has the best shot has to happen instantaneously, because these things are not just lollygagging around. They're coming in very hot. And so we're learning a lot of stuff all the time. Of course, the basic stuff. Yeah, UAVs are going to be incredibly important going forward. And then counter UAVs are going to be important going forward. And so we're just learning lessons all the time. I'm sure that Taymor and David will probably have other stuff they'd like to add to this as well. So I will.
I do. And I think Mike Tyson was quoted as saying that everyone has a plan until you get punched in the face. So the two conflicts that PK just mentioned, right? We have heard and we have seen over the past year to 2 years, assets essentially being exchanged in between. So for example, commercial products that go out, they have cameras, they have storage, and they get into the enemy's hands. What do they do with that? They take it apart, they look at it, and they identify your tactics. They come back and they attack your tactics, because that's how you win wars. And so What we need to do on our side is to make sure that anything that you deploy out there needs to be secure and it needs to be safe. And that's both on the software and the hardware side with anti-tamper as well as cross-domain solutions.
Adding to that, all the systems really need to be upgradable as well. So they have been literally
Yes.
upgrading Patriot systems with software upgrades from the start of the conflict until now, and it's periodic. And so they could shoot down hypersonic missiles now because of software upgrades. So that's another key thing is, don't expect the weapon system you start a war with to be the one you end up with a few months later if it has
Yes.
software upgradability in it.
Yeah, no, thank you. And this, David, and that was going to be my statement is we're seeing that evolution, right? That needs to occur. This isn't something that you can, oh, there's a problem, I'll fix that problem, and on Patch Tuesday I'll send it out. It has to move quick. It has to move very fast. We have to see it. We have to be prophetic and understand that we have to be in places we maybe didn't anticipate. And how do we get there? And how do we answer the problem that's at hand, or the problems that we expect there to be, or predict that there will be, not expect, but predict that there will be. So that's where these that's maybe a little bit outside of these standards right now. Hopefully, again, as we continue to get better with our models, and we gain more data. Again, as stated earlier in the webinar, AI requires a lot of information, and then as we get that information, as we continue to collect it and continue to run our models against it, hopefully we get some insights and knowledge and be able to implement some wisdom. Over.
All right, thank you all. So this question is directed to all speakers. The question is, we are all building data centricity mainly on DDS as a major open system. What about the integration with NIEM, and how will industry standardize on these data-centric standards? And they added, major concern is how we guarantee minimal latency in a SOS architecture.
Cool. I guess since I'm the DDS guy, I should answer it first. But before I forget, I'm going to use left of the boom all the time, David. So thank you for that. I'm going to steal that shamelessly. So yeah, one of my colleagues always shows the slide saying, I've got 24 different protocols defined here. I'll define a new one that's going to be unifying and have all that. Well, now I have to support 25 different protocols. And so, for NIEM or any of the different connectivity that's going to be used in CJADC2, there's going to have to be gateways built in between that. And they'll have to be very much, figured out how, whether it's going to be MQTT or DDS or, the NIEM standard, they will have to be very correctly glued together so that you can have a seamless, very much low latency. And so this is something that almost all the connectivity folks do real well in terms of DDS. There's gateways and other stuff all around. We have a thing called routing service, and talking to things in the cloud and being able to translate to different formats is just something that any data connectivity framework is going to have to do well to play in JADC2. Unfortunately, DDS does that very well now. I'll let my colleagues speak if they'd like to.
Yeah, David, I was going to say, so latency is a bit of it's like saying, well, what's hot? It's a little subjective. So latency, again, a lot of experiences where, many seconds of comms delay is, that was a lot of latency, but you still had to have the conversation. You used to just be patient. Versus now, and in the days and the technologies we're so used to, especially here in stateside, especially in nice rural areas. We're 5G ultra wideband, and we if I don't have the top 5 million answers on my phone within nanoseconds, before I blink my eyes, I'm upset. So it's one of those things. There's a large spectrum for what is speed, what is latency, and in parts of the world where we start talking about cloud edge, especially when we start talking about tactical and where are we going to be. Again, going back to some of those our discussions in the models. Yes, data centricity is functionally critical. The network has never been less important or unimportant. It has to be there. It has to be there in droves. We have to find ways of bringing robust comms, and that again everything that's been talked about. LEO, MEO, GEO. modular open radio standards. There's all sorts of new methods. We haven't 100% seen everything successful yet, but the effort's going there. So yes, even we do need comms. We need to ensure that there is a network and find those efficiencies in that network. Over.
Great, thank you very much. So I think we got time for maybe one more question here. This one is directed to David. How can the CJADC2 community better collaborate and document ideas for interoperability?
Man, I don't know why you're directing me. That was my seed questioning. We're supposed to direct at me. I wanted to hear from everybody else because that's where I find the challenge is that there is, CJADC2, CJADC2 is out there. Again, in my experiences, when we start talking about mission sets, security is the stumbling block, and where can those conversations be had, and where can those exercises be held, and who has access to what? It's extremely limiting. Again, there are security standards such as who has a security clearance and how does that security clearance process, support the people who need to be there. I'm not saying it's wrong. I'm just saying it is a limitation. There is a restriction there. So we don't always have the brightest minds and the access to the most technology and access to the best ranges and access to the largest sample of data when we need it in order to really hone our skills when it comes to JADC2. But anyway, I would love to know the answer to that question. That's why I was asking it. It's just hopefully
I can add, a few words from, my perspective, and I agree with everything you said. But, I think the way to do that is just to keep doing that. So when the Army started doing this back in 2020 with Project Convergence 2020, which they cleverly called PC20, and they did it again in PC21 and PC22, and now there's one coming in PC24. It's not just let's try this for a day or so and see what happens. It's bang on systems. It's get systems from Australia and Britain and the United States and go for 2 months and just see what happens and then document it and then learn from that. And so the Navy's doing that with some upcoming exercises as well. And to be clear, the Army exercises are all joint. So the Navy's involved, the Air Force is involved. There's F-35s flying, all that good stuff. So I think that's the way to do it. You got to just keep trying to improve and learning from your mistakes. Move fast. Don't sit around and make a committee and figure out 3 years from now what's going to happen. No, go out in the field today with what you got, and how can you improve it today? I think that's a way to improve and get there quicker. From my perspective.
Absolutely, and I'll chime in with my 2 cents in that. How can we work together as industry, and how can we work together, industry, government, and also pull in commercial, right? With security being the most important key feature. We have at Mercury Systems, we've worked with AVMS Convergence as well as Overmatch folks, whether it be the digital infrastructure, whether it be the TMVM, and all the other efforts, commercial open solutions, for example. And it's very simple. It's very easy. Provide us with your high-level overview of what you need and let us figure it out. The 3 panelists here, myself, Dave and PK, our companies spend collectively between the 3 companies probably $500 million a year on research and development. Where should we put that? We can go with it on our own, or if you provide us with the solutions that you need, or at least a high-level need, we can help get you there. And so I think that in itself can help fuel the innovation that I mentioned early on, and how Dave, myself, and PK can collaborate to field solutions so that the warfighters can achieve their mission.
Great. Well, I think that's, we have a few more questions, but I think that's all the time we have today. Sorry we could not get to all of your questions. Someone may get back to you after the event with more information. I would like to once again thank PK, Taymor, and David for speaking today, and Mercury Systems, Curtis Wright, and Real-Time Innovations, RTI, for sponsoring this session. This and all Open Systems Media virtual events and webcasts are copyrighted and may not be recorded or used in any way without the express written consent of Open Systems Media. This event will be archived online today at the same URL you used to join today's live session, as well as the URL shown on your screen, and will be available for at least 1 year. Please be sure to attend our second session, How AI Enables CJADC2 Capabilities, starting at 10 a.m. PST, 1 p.m. EST. Thank you and have a great day.
Thanks, everyone.